Kidney that you need to know. The kidney is surrounded by a protective sheath called the capsule. And then there are three primary regions. From here to here is the cortex. The cortex contains the majority of the nephron. Nephrons are the actual units within a kidney that actually clean the blood. That's their job. But now the nephrons are also down, they start in the medulla. So from here to here is the medulla, and then we have the pelvis. The pelvis drains all the urine that has been produced, and it drains it down the ureter here. So blood vessels, you have to know the blood flow through the kidneys, and there's a nice flow chart in your book and in your lab or in your notes. So the renal artery brings the blood into the kidneys. It's full of oxygen, but it's also full of anything that needs to be filtered out of the body. So we first break into what's called the segmental artery here, and then that you can see will branch, and these branches are called the interlobar arteries, and then they come and see how they make this like arc. That's called the arcuate artery, and then the arcuate artery goes into smaller, what we call interlobular arteries, and the interlobular arteries split into what's called the afferent arteriole. The afferent arteriole is a small vessel, and every afferent arteriole goes into this ball of capillaries here. This is the ball of capillaries. So if you look here in this model, this is the ball of capillaries. It's surrounded by what's called the Bowman's capsule. This is called the glomerulus or glomerulus. And what happens is that the afferent arteriole comes in, and then you will see all kinds of materials forced out of that glomerulus and captured by the Bowman's capsule. Once the blood goes through here, it comes out over here in what we call an efferent arteriole. And the efferent arteriole hopefully doesn't have anything bad in it. Hopefully everything that needed to come out of the bloodstream did here, came out inside the glomerulus and has been captured by the Bowman's capsule. And then it's going to go into what we call the convoluted tubule. There's three parts to the convoluted tubule. So this is this ball of capillary, this would be the Bowman's capsule, and the glomerulus is inside. The convoluted tubule, the first part is called the proximal convoluted tubule. That does the most filtering. And then it goes into the nephron loop, or the loop of Henle. And then we go into the distal convoluted tubule here, which leads into the collecting tubule. And you'll have a collecting duct here that will collect it will collect from various other nephrons. This is one nephron, this is a nephron, this is a nephron. And we'll go through that, and it's in your lab manual. We'll do that later. So the kidney itself, so once we came up to the interlobular artery and split into the afferent arteriole, the afferent arteriole will lead into, you can see here all these little balls. Those are all Bowman's capsules, and they're all doing filtering of the bloodstream. And you can see the nephron here. You can see that the collecting duct goes all the way down, and then those will drain. So like every one of these are called the renal pyramids. All these pyramids will have collecting ducts in them that will drain the urine down into this cup-like structure here. There's a papillae in there, renal papillae, and it will drain into what we call the minor calyxy. And then all the minor calyxes drain into a major. This is a major. This is a major here, right through here. And then that will drain into your renal pelvis and down the ureter. Meanwhile, that blood should be clean. So anything that you needed to get rid of, nitrogenous wastes, which are the major component of urine, any kind of toxins, any extra salt, any extra electrolytes, anything the body needed to get out of the bloodstream, hopefully should be in that urine. Now, the glomerulus needs to make decisions about what needs to stay in and what needs to stay out. So, and sometimes it makes good decisions and sometimes not good decisions. But if there's glucose, hopefully the glucose has been returned to the blood. If it somehow got out of the bloodstream here and went in to be filtered, there's a backup plan. And what you'll see is the entire convoluted tubule is actually surrounded, and this model doesn't do it justice, but it's surrounded by what we call a paratubular capillary network. And those paratubular capillaries have the job of either reabsorbing materials or secreting materials. The paratubular capillaries that wrap around this, and I'll do this in lecture more too, they can decide what needs to stay in and what needs to come back out. Meaning that what needs to stay in, meaning it stays inside the nephron so you can urinate it out, or it reabsorbs it back in the blood because you need it, like glucose. But you want to listen in the lecture notes for that. The bloodstream then, once the blood is cleaned, then you will see there is an interlobular venule, and that goes into the, well, I shouldn't say that, it's an interlobular vein. The venule here comes off, but it goes down through there into the arcuate vein, and then the arcuate vein merges into the interlobar vein, it's a mouthful, then into the segmental vein, and then back into the renal vein. And again, we'll go through that in the lecture notes too. So these are the renal pyramids. These are housed within the medulla of the kidney. So I loaded a picture of the kidney for you to label all these parts, including the vessels. So make sure you do that. That's part of the kidney lab worksheet that will be on Rock for you to download and fill out, and then scan and then put back in the Dropbox. So that's it for kidneys for now.